Hello guys, in this video we are going to solve nonlinear equations using Excel, and in previous videos we saw that we could solve a nonlinear equation using OpenMDAO, and this is the same equation that we had there earlier, and we have seen the answer to that equation. It was 7.54 for x equals 1, and now we're going to solve it with Excel's solver add-in. So in the search bar, I'm going to search add-ons or add-in. I'm going to hit on this icon here. As you can see, I'm going to make sure that the add-ins are available. The solver add-in should be available. And into the data tab, I'm going to hit solver, and I need to write the equation in a cell. So I'm going to write cosine of x, which is 1, times y. I'm going to select its cell minus sine of y times y. That's it. I'm going to hit enter. No zeros, no nothing, just the equation. Okay? That's it. Initially, it's going to set to 1. Okay? And I'm going to make sure it takes degrees as input. So I'm going to check. Okay? So I'm going to convert it to degrees by multiplying that to pi over 180. Now it is 1. So I'm going to use that conversion to make sure that the equation is taking degrees as inputs. That's it. Times pi over 180. And now it's ready. I'm going to hit solvers button here. The set objective should be equal to the equation cell, which is here. And I'm going to set the to value of 0. The objective should be equals to value of 0. And by changing the variable cell, which is y, I'm going to choose its cell. And I'm not going to change the nonlinear solver. I'm going to hit solve, hit continue again, and that's it. Solver found a solution. All constraints and optimality conditions are satisfied. And the answer is 7.54, 745, as you can see. So let's solve this in EES application as well, in the engineering equations solver. I'm going to write the equation just as I did in Excel. Cosine of x times y minus sine of y times y equals 0. I'm going to give x1 as its value, and that's, I'm going to hit either F2 button or its solve button right here. So I'm going to hit it again. Apparently it didn't work the first time. Yeah. And value is found. 7.547 is the value. Let's change its decimals to much more places, decimal places. I just want to check the precision. 7.547449. And you need to change the options on the solver and make its constraint precision more. If this value was set to a lower value, like 0.001 or whatever, just add some zeros here to make it more accurate. Just like this. Let's solve another nonlinear equation. Okay. Inside EES, I'm going to comment those lines, previous equation. And the equation 2 is this nonlinear algebraic equation. As you can see, this is a nonlinear equation, and we're going to solve it using both Excel and EES. The C is the constant, equals 1.32473. It's not going to change. And the equation cell is right here. So we are going to write this equation, which is variable, is mz. Mz is the axial Mach number and a positive value. It's not going to be negative at all in our equation. So this is going to be a constraint, which we will be adding it into the solver's constraints. Now I'm going to write the equation 1 plus 0.2 times the mz cell by the power of 2 minus c times mz by the power of 1 over 3. That's it. No equal to 0, just the equation itself. Now I'm going to go to Data tab and I'm going to hit on Solver. Set objective is going to be my equation cell. It's going to be to the value of 0 by changing the variable cell mz, and we need to add our constraint. So I'm going to delete that and add the constraint so you will see how it is done. We are just going to click add, and then cell reference is going to be the mz, the actual mz, not this lower cell. It's going to be bigger or equal to 0, so it'll be positive. I'm going to hit OK. That's it. I'm going to hit solve, and it's going to find the value. As you can see, with respect to that constraint, the equation has converged to a value which is very small, close to 0, and the mz is found to be 0.497139. Now inside EES, I'm going to write the equation here: 1 plus 0.2 times mz by the power of 2 minus c times mz by the power of 1 over 3 equals 0. C is going to be 1.32473, and that's it. I'm going to hit F2, or the solve button up here. I'm going to hit it again. That's it. The MC is found to be 0.49, and I want to show you that I have added a constraint here by setting the bounds for the variable. If I set it to minus infinity to infinity for mz, we're going to have a problem. It's going to raise an error because it cannot solve this equation. So we're going to set it to 0 to infinity for mz, and then hit solve, and that's it. mz is 0.497139. Please subscribe, guys, if you found this video to be helpful. Thank you.